Hello everyone. So today we will be designing WhatsApp. It's also a very common question asked during system design interview. Let's get started. We will first discuss about the system requirements and the functional requirements and design our system based on them. So let's list down the functional requirements. First is one-to-one chat. Second is group chat. Third is last seen or online status. And the fourth one is sent and delivery receipts. And the fifth one is sharing of media files. Good. Now let's list down the system requirements. First, we should have low latency because it's a messaging service, so messaging system. So we can say low latency. You can say it is a real-time system. Real-time system. Then second should be the system should be highly available. So here what is about, like when we see the CAP theorem, we can either go for consistency or availability, and in this case we are not having some things like a banking system where the transactions are happening, but we really want the systems to be highly available, so we will prefer availability with respect to consistency. And the third one is highly rare. The system should be very secure. Right? And the system should be scalable. The system should be highly scalable. Right. So keeping these requirements in mind, let's start designing our system. So if we talk about what we need for a person A to talk to a person B over the internet, maybe A should know the address of B and should be able to send a message to B. So just for simple sake, let's draw here A and B. So we say that A wants to talk to B, but A don't know the address of B. So we need someone who can help him, right? So we have an application server here. An API server will help A talk to B. Yeah, like this. But how they will talk? Can they talk over HTTP? Let's spend some time and discuss how HTTP works. In HTTP, the client initiates a request and the server responds back, right? But the server cannot initiate a request. So if A wants to send a message to B, it can send a message to the API server, say, oh, I want to send a message to B, but the API server cannot send the message to B unless and until B initiates a request to the API server and asks, hey, do you have any message for me? So this will not work because we want to design something like a real-time system in which we want to send the message and B should get the message as soon as possible. So if talking about HTTP, how does it work is, we want to draw here as a client and as a server. And the client initiates a request and the server responds back. Request and response. So this doesn't work for us. Next, what we can have something called HTTP long pooling. Will HTTP long pooling work? And how does HTTP long pooling work? So if I say HTTP long, okay. In HTTP long pooling, what happens? Client A initiates a request or sends a request to the server, and the server keeps the connection open for a long time. Okay, it's a persistent connection which keeps open for the long time, and as soon as the server gets something which has to be sent or forwarded to A, it sends it and sends the response back to A, and the connection closes. And when A receives the message, at the second moment A initiates another connection and keeps the connection again open for a long time. So it works something like this. If we have a client here, a server here, the client initiates a request, and this request remains persistent for a long time. Response. And as soon as the server gets something for A, it sends the message to client A, and the client A, when receives a response, it initiates another connection, keeps the connection open. Now this can work for us, but it's very heavy for the server, right? Because the server has to keep the connection open without use for a long time. Also, it might not be real time, because it's possible that when the server is sending a message to A, at the same moment the client B sends another message to for A, and that takes some time before it is delivered to A, right? So what is the third option which might work for us? The third option what can work for us is called WebSockets. Now, how do WebSockets work? So it's same client and server talking to each other, but here we get the facility of having a full duplex connection open for as long as a client or a server wants it. So what happens, we say a client and a server. The client initiates a request, and the server responds back with a handshake. And after that, there is a persistent duplex connection between them open. So now the communication can be real time. As soon as A sends a message for B, since both A and B are connected to server A, server can directly forward the message to B at the same instance. This is the thing what will work for us, and this is the thing what will work in any messaging system like WhatsApp or Facebook Messenger or Instagram Messenger, any of the system design. So from now we'll start our designing our system, further extending the system, keeping in mind that we are using WebSockets for communication. One more thing to mention about WebSockets is like WebSockets use 16-bit for port addresses. So one server can have at the max around 65,000 connections open for us. So WhatsApp, like example, has like billions of users, right? So one server cannot work for us, so we need like thousands of servers. So let's continue and take some space and start designing our system. So we have multiple clients connected to our system. Let's start with drawing the clients. So suppose we have 1, 2, 3, 4, and 5 clients. So we say it's as A, B, C, D, and E, right? And then we'll have multiple API servers as well, because each server, as I told, will support 65,000 connections, so we need a number of servers to support billions of users, right? For an example, we take like 4 API servers here. Then we need a load balancer so that clients can the load from the clients can be distributed equally or in a sensible way among the servers. We can use a algorithm like round robin distribution out here. say load balancer. Right, and these clients are connected to the API server via these load balancers. So let's draw these connections, possible connections. Suppose A, and A is connected to server 2, B, and B is connected to server 1, C is connected to server 3, and D is also connected to server 3, and E is connected to server 4. Now, suppose there is a case A wants to communicate to D, then A has to send a message to server B, server 2, and server 2 has to forward the message to server 4, which has to forward the message to server to the client E. But then there has to be some way in which A can know, or the API server 2 can know, to which API server E is connected to. And that's here why we need some kind of service called like a messaging service, right? We can have something like a pub sub system. So these API servers are subscribe to this publisher subscriber system, and they know which basically gives them the information to which API server the node or the client they are looking for is connected to. So if we draw here something like a messaging service, and we say that this messaging service is scalable, so we have multiple instances of this one, and I write here message service. And these API servers will be connected to this message service. Right. Now, one thing can be there can be many times when the same API server or different API server will ask for similar information, right? To which server C is connected to. So it's very sensible to have something like a cache from which the messaging service can pick this information very frequently. This will make our system very fast. So we can add here something like a cache. This can be a distributed cache like Redis. And this messaging service is connected to this one. Nice. So now we have some system in which A can talk to B quite easily. Now, we know in WhatsApp that the messages are not stored. As soon as the message is delivered, the message is deleted from the database. They don't exist. But for that time being, if the message is sent and the message is not delivered because A or B is offline or some other condition is there, we have to keep the message somewhere, right? And also we have to keep the user information and some kind of message format information or the group chat information in some database. So we need a database here. Now the thing is, what kind of database do we need? Do we need a SQL database or do we need a NoSQL database? Here we will go for the NoSQL database. Why? Because the NoSQL database is highly available, it's highly scalable, and it's very, very write heavy. We know that we'll have billions of users connected, and at the same time, so many users when writing to the database, an SQL database might not be a very good option. That's why we choose a NoSQL database like Cassandra. So let's draw here like we have a database. And we say is like DB. And the messaging service is connected to this database. Nice. So we have like a system working for us. Now the next requirement what we had was send receipt and delivery receipts. How that will work. So for this we basically need, since we have the connection between the server and the client bidirectional, so as soon as the message is delivered to the respective client, it has to be the information has to be sent back to the messaging service, and the messaging service has to forward the message to the another client as it asks for. Suppose for an example, A wants to send a message to E. So what happens? A basically sends a message. So A sends the load balancer and goes here, and then this goes to the API server 2, and API server goes to the messaging service and asks, okay, to which server is E connected to? The messaging service tells API, okay, E is connected to API server 4. So what it goes and sends to the API server 4, and the API server 4 forwards the message to E. As soon as the message is forwarded, it gets back a reply, and the same reply is sent back to API server 2, telling that, okay, the message is delivered. Now you can inform A that the message is delivered. So this is how the sent and the delivery receipts can work. And this is being covered in our system now. So what's next is left in our system. So we also talked about group chats. How we will support group chats in here. So for supporting group chat, there has to be a way so that the API servers knows to which particular group which users are belonging to and to which API servers these users are connected to. So we can have the same information in the same messaging service, but it will be more optimal to choose for another service which can manage these group messaging on a separate scale. So if I have another messaging service like I say is, let me take black, group message service, and whenever there is a group chat, at that time this API servers will talk to this group messaging service, then this messaging service. So we'll also have connections from here to here. I think it's better to take some other color because it will look, take it yellow. Yeah, and this will also be scalable, so we can add one more server like here, and also we will have another cache connected to this. So this is how we can handle the group messages, right? But in the database, this is also connected to the database, we need to save the information about the group and also about the users. So we can have two tables. Considering the two tables out here, what we can have in the system is one of the user table. Let us try to write how these tables might look. I would say, let's write it here. So I would say I have a user table which has an ID, is an integer. It has a user name, which is a phone number, because everyone is identified by using a phone number on WhatsApp. And then also it has a last seen timestamp. And then we can have another table called message table. So I would say this is the user table, and let's draw one more table. Let's take some space here and try to draw another table here. So we say another table will be like message table, and what it will have, it will also have an ID which is an integer, and then it will have text which will be our message, which will be string, and then it will have a URL so that we can support the media files, which will be also a string, right? And then we can have another table called groups table, which will have ID as the group ID, which will be an integer, and it will have users, so it's a key value pair. So we'll have all the user IDs that will be a foreign key to the user table out here. So these are the tables which we might need in order to get all this information and save all this information out here. So let's get back here. So should we move this user table down? Yeah. Nice. Okay, so we have it clean here. Now what's the next thing we are talking about? What's left in our system design? So we talked about single one-to-one chat, we talked about send and delivery receipts, we talked about group chats. Now we have to talk about media files, right? How will support media files? So suppose A is also sending a image or a video or an audio file along with its message. So the API server, it gets a message. So we have to save something kind of URL. We cannot save this whole audio, the video message on the same database. So we will save this in something like a distributed file system like S3. So we can have some space here, and we can, suppose we select something like S3, which is simple storage service from Amazon. S3 for all our media files. So what happens, as soon as the server receives a media file, what it'll do, it'll go and save this media file. Let me take a link here. Suppose server A gets it. Server A goes and saves it and then copies the same URL of that media file in the message before being forwarding to the messaging service or the group messaging service. In this way, when the message is forwarded back to the client, suppose the message was for client from A to E, client E receives the message, it has a URL in the message for which it has to download the data. So what E will go do, it will basically go and directly download the information from S3. That's how the media files will be saved and communicated. Now, we can also have a CDN here so that we transfer this information really fast if the same information is being asked again and again. So you can say, like, we can draw here content delivery network, and then this can take care of, this can cache the information. So E, what it'll do, it'll ask for this information first from the CDN. If the CDN doesn't have this information, then it'll go and fetch the information from S3 and keep it in its cache. I think we covered almost all of the things. The last scene, the next thing what was left was last scene status, what is shown on WhatsApp, how it will happen. So if you remember, we designed the database, the users table, and there was something called, in the users table, there was something called last seen timestamp. Okay, so what this messaging service can do, this messaging service, as soon as the user communicates or tries to send an information to someone, it tries to update in the table the last seen, that particular timestamp. And when some other user has opened that particular user's information on his application, that last seen information is fetched and is shown on its screen. So we can have a time difference, like from the current time, if the last seen is like 3 seconds back, show the user as last seen as 3 seconds. If it is like 10 minutes, then you just show that the user is on offline, and that should be configurable. I think we covered almost all. If you have almost all the requirements what we stole, if you have any questions, just post it below, and do like and subscribe if you want me to upload more videos. Thank you.